In this video, I'm going to mess around with gRPC. That's Google's high performance open source universal RPC framework. I'm going to use Python. What I'm going to do is I'm going to create a Python client server. It's just going to do some ping pong tests, and I'm going to achieve 10,000 RPC calls in 2.5 seconds. And I'll show you how I do this. So I'm not going to do anything too complicated. This is kind of just gRPC beginners code. And also there will be there's a project on GitHub. There'll be a link in the description with the code that I'll be writing. And after I finish writing the code and I demonstrate the 2.5 seconds, 10,000 messages in 2.5 seconds, I'm going to install a server in Singapore and a couple of clients in Frankfurt, and see what kind of performance we get. See if I still get 10,000 in 2.5 seconds. Very unlikely, but let's try it anyway. Okay. So let's get started. I'm going to use Visual Studio Code because I can. Rightio. First thing I'm going to do is create what they call a proto. Let's create a folder called proto. Excellent. I'm going to do this quite quickly. Inside that, I'm going to have a file called pingpong.proto. Pingpong.proto. Excellent. And that syntax equals proto3. Excellent. Okay, so I'm supposed to have comments. My proto, my ping pong proto file. Okay, I'll show you various things as we go through this. I'll keep it nice and fast and simple. Okay, so we need a service, and I'm going to call it the ping pong service. Okay, and in there's one RPC call, and it's called ping, and the message incoming will be a ping, and it returns a pong, and then we just have that bit there. Okay, so next we will describe the messages. So it's a message, and it's called ping. All right, so there we go, and there's an int 32. Count is my variable. And what I'll be doing is sending, my client will send a number, the server will increment that number and reply it back with the pong. So this is how we can count how many messages the client has. We'll know that there's 10 clients, that they all got their 10,000 messages back. What I discovered, this is kind of quite reliable as well. Okay, so message pong now, and that's also is an int 32 count, and that's the value that gets returned. Now this these messages behave a lot like enumerators, so I can do string my name equals 2. It's not really a string, is it? Float my float equals 3. Yep, they're like numerators. They're not really. If you do that, it will come out wrong. See, I have a proto highlighter in my Visual Studio Code. That's why, so I can tell that there's errors straight away. Doesn't matter. Anyway, I'm just going to keep this real simple because this is just the beginning one, and I do this nice and fast. So that ping pong proto is good. What I need to do now is compile that using a thing called proto. So I will need to quickly set up a virtual environment and install that using pip. So I'm going to do that right now. I will fast forward these bits that are quite slow. Okay, there's venv over here now. Okay, it's done. Okay, now I need to source venv scripts activate. Okay, done. Pip install gRPC.io. That's one of the requirements. And tools. Okay, that's those two things. So now we're going to compile pingpong proto. To do that, I'm going to write Python m gRPC tools dot proto. Now for the command line arguments, slash proto, that's this folder here, proto, and my out folder, Python out equals .gRPC Python out equals dot, and now dot proto pingpong dot proto. Okay, so what we got here is, I don't know why we have to write this twice, iProto and then slash proto there. But anyway, let's press enter. Okay, that's done. This line is quite complicated, so what I've done is quite complicated to remember. So what I've done on my GitHub is actually just pasted that into the as a comment, so you can quickly copy and paste that and run it. Okay, so what it's done is now created these two extra files here. One of them says do not edit. It's generated by the protocol buffer compiler, and it describes quite a few things, and it describes the protocol mostly. Here we go. The protocol, the protocol buffer message. You can sort of see that, and there's a whole lot of other stuff. You don't really need to understand how that works to run this demo. And the other file is, it creates the service stub and a service servicer and a function to start the server, or to reference the server. The server component will use this one, pingpong service servicer, and the client component will use this one, pingpong service stub. Let's go and create the Python servers and clients now. A new file, server.py. Excellent. Now in server.py, I will import several important things from concurrent import futures. This is because it will run a thread pool executor. Let's import gRPC. Yep. Import this pingpong pb2 that I just created. I need to import the other pingpong as well, gRPC. I will import import time, because I'll log the time, and I'll import threading since I want to log the amount of threads that are running behind the scenes, because this is one of the things I'll show. So class listener, this is for the server, and it's going to use the pong is going to inherit the pingpong gRPC pingpong servicer. And let's define a init self.counter. This is what I'm going to use to measure how many messages last print time, how many messages it sends in a certain time frame. Okay, now define ping self request and context. Okay, self.counter plus equals 1 if self. I'll fast forward this bit. This is about me printing every 10,000 messages. I will print the time, how long it took for me to process those 10,000 messages. Excellent. And what with the ping RPC call, which is described in proto up here. Ping. Oh, it's ping. It returns. Golly, that's a little bit of leftover from C. Doing other C languages. Return ping pong pb2 dot pong. This is the message, and in there I got count equals request, which is this thing here, request dot count plus 1. All right, format. Don't have a formatter, so install a formatter. Okay, there we go, formatted. Alrighty-o. So what do we got here? Pingpong gRPC pingpong servicer, which appears in this file here. Nope, this one here, sorry. There's the servicer, that's this function here. And it ping, that's described here in the proto, ping. And we return a pong, pingpong pb2 pong. There we go, it's a ping and a pong descriptor, pong. It's all in there with a new count. And so here we're reading the count from the request, which is the in here. So I've got a count here, and server we're responding with a new count, which is on the pong count. There we go. Excellent. That's not finished yet for the server, but let's create a function now called serve, which we'll use to start this off. Okay, so the server equals gRPC dot server futures dot thread pool executor max workers equals 1. I'll show you what happens when you change these values in a moment, or during the tests. Ping pong pb to gRPC dot add. There we go. Ping pong servicer to server. That's over here, isn't it? There we go. Add. This is it creates the handlers through request and response, deserializer and serializer. Yep, it's all there. Let's go back to server. What it needs is a listener, which is what I've created up the top here. Server, which is I just created just here. Server dot add in secure port, and this will be an IP6 compliant. And I'm going to use port 9999. Many different ports, whichever I want. I'm going to use that one. Server.start. Okay, and let's just put some stuff in there. While true. I'm just going to print. I'm going to print how many. I'm just going to make print a simple message like the server is actually running. Server on, and how many thread counts, how many threads are running, which we'll see. %i %, threading dot active count. Okay, time dot sleep 10. So this will run every 10 seconds. Except keyboard interrupt. Print keyboard in. Just wanna server dot stop 0, and we go. What's wrong with time sleep? Strange. Anyway, Control F to format. So I need another one of those. There we go. Excellent. Now, if name equals main, let's serve. Excellent. That is a server using the gRPC pingpong proto buff. Let's try that out. Okay, Python server. Radio, just allow access on Windows. Okay, server on every 10 seconds is just going to tell me how many threads there are. There we go. Control C to stop. Let's create a new file for the client. So client dot py. Kidoki. Now the client, I'm going to import OS because I want to just log its process ID because I'll be doing a multi-process version. I want to import the same old compiled protobuf files from before. So there's pingpong pb2, import pingpong pb2 gRPC. I want to import time because I'll log that as well. Import and gRPC, that's important. Say, let's go to function run. Okay, and in here I will have a counter and it equals 0. This is the counter that I will send to the server, and the server will increment it and I'll get it back. Is the so that's the count that I'll be sending. Okay, and the process ID, because I want to sort of log that to the console as well. Get PID os.get PID. There we go. Now with gRPC.insecure channel localhost. Oh, that's interesting. Yeah, I'll have to change that later. 9999 as channel stub equals pingpong gRPC dot pingpong server stub channel. Rightio. So while true, try start equals equals time dot time, and response equals stub dot ping. There we go. We know what that is. That was in my proto, and it's been generated down here in the stub code. Ping pong server stub. There we go. There's a ping, self dot ping. Client response equals stub ping. So, and the message that we're sending is a ping pong pb2 dot ping with the contents being count equals my counter. Oh, there we go. Enter. Now counter equals response dot count. Now this now equals the value that the server gave back to me. If counter mod 1000 equals 0, basically every time the counter is divisible by 1000 exactly, I'm going to print just some stuff to the console, like 5% 4f response equals %s and the proc ID equals %i percent time dot time minus start, which is up there, yep, comma the response I got back from the server, the count value more specifically, and the process ID, which I've just got up there. Excellent. So try, that's good, except keyboard interrupt, and we'll print that out just because and I'll do channel dot unsubscribe close. This is a function I'll be calling. Now, if you have been experimenting with gRPC, there's this kind of issue that appears occasionally where the client hangs when you're closing the channel, and this version of gRPC I've got hasn't quite resolved that issue yet. It's just very intermittent, and you may happen once or twice during this video, but anyway. So create a function for close channel dot close. If name equals main, then we'll just run it. Okay, so yeah, because what we'll do is we'll call this client directly just to demonstrate it. We'll set up a few processes that call the client directly, and we'll also run this from another file I'll create called multiprocess. Let's try this client out now. We'll start the server up. Excellent. And we'll start a new little window down here. Python client.py. Okay. Module has no attribute ping. Rightio. That's right, should be a capital, because over here my proto, my RPC's got a lowercase p, but the messages have an uppercase p and a pong. So let's try that again. Client. Okay, so here we go. Got 3 threads running on the server now. 10,000 calls in 32 seconds there, 4 seconds. Getting 10,000 calls in 4.37 seconds. Okay, so one client here has sent 50,000 messages now, and the server down here on the bottom left is responding very, very quickly. 3.7 seconds, 3.7 seconds, 3.7 seconds. Actually, my screen recorder might be causing that to be kind of slightly slower. Doesn't matter. Let's start up another process here on the right. Let's get rid of that. Python client py. This is another process, and it's sending another 1,000 messages super fast to the server. The server, here we go. It's now processing these messages. 10,000 calls in 2.65 seconds. So that little server has 2 clients sending it messages now, and it's processing those in 2.5 seconds. Let's have a look at my CPU. There it is. Let's see what it looks like. Let's graph summary view. So my server's working quite hard there. We can see that all the 8 CPUs are, one of them's maxed out, 2 of them are maxed out there. So it's handling, it's all multi-threading pretty nicely. I didn't really have to do much. You can see I just wrote that in that space of time there. All right, let's have a look now. What happens? I'll just close that. Then I'm going to stop the server, and both the clients then disconnect. What I'll just demo now is quickly upping the max workers to see what effect that has. I'm going to create 4 max workers and see what happens. Start a server, a client, and a client. 10,000 calls in 2.7 seconds. 10,000 in 2.6 seconds. 2.5 seconds. That's the bottom left I'm looking at down here. There we go. 2.5 seconds. So changing the max workers didn't really do anything. Let's really increase the max workers to 100, say. Let's try that again. And there we go. .8 seconds, 2.9 seconds, 2.7 seconds, 2.8 seconds, 2.8 seconds. Is that the max workers? I'm not entirely convinced. Maybe. Let's look at the CPU. CPU doesn't look any better than it did before. It's just working pretty hard. I'm going to 2.6 seconds there. I'm going to close this window. You can see I've got 102 threads running there. There are 2 threads for the server plus 100 worker threads. 2.8, there was a 2.6, 3.1, 3.0. Let's start up another client, see what happens. Actually, I'm just going to just reduce that back down to 1, just to show you how good that server is. Okay, so we got, let that sit for a second. 2.8 seconds, 2.7 seconds. We've got 3 threads running. 2.6, 2.5, 8. 2.55. Anyway, let's start another client, see what happens. Python client. Audio. Still processing 10,000 calls in 2.4 seconds there. 2.4 seconds. Let's start another client. Python client. 10,000 calls in 2.6 seconds. So I've got one max worker on the server, and I've got 4 separate processes with clients in them running. My server's probably seems to be working quite hard now. See if we can see this little client here 4 has sent 30,000 messages. This one sent 55,000. This one says sent 105,000 messages, and this first one sent 108,000 messages. Let's just stop all that. What I'll do now is I'll create a client, another script called multiprocess, which will start up lots of clients. So it's called multiprocess.py. Excellent. And in there, I'm going to import. So from multiprocessing, import process. Excellent. Import the client. Import client as client. There we go. Don't really need that bit, but anyway, if name equals main count equals 2 processes for the moment. Processes equals a dictionary for x in range caps lock count processes x equals process target equals client dot run, which is a function in my client code here. Where is it? Client dot run, and because we're calling this from a process here, sub process, it's not going to actually execute this line here because the name won't be main. I'll print that to the screen for you. Print name. There you go, just so you can see once I start it up. C for x for x in range count processes x dot start. Oh yeah, let's try that out. Let's see whether multiprocess works. Okay, so server, let's start server again. There we go. Let's start a new little window. Python multiprocess. Okay, so it started. Yes, there are 2 process IDs running, and you can see they're both just sending 1,000 messages at a time. I'm getting a rate of 2.2 seconds now for 10,000 calls. 2.2 seconds. You know, multiprocessing has a process pull option, but I just find starting processes like this it's always faster. 2.2 seconds. That's 10,000 calls. 2.2 seconds. 2.23. 2.21 seconds up there. Excellent. Let's see what happens if I start up another multiprocess. Python multiprocess. 2.3 seconds. It's pretty much maxing out there. My video may not be recording very well at this particular point in time, but let's look at the CPU anyway. Let's have a look at that. My CPU is maxing out on 2 processes. Third one, well, it's 3 processes. Maxing out on 3 processes now. Processes. Okay, let's just get rid of that. Rightio. There we go. See how I press Control C on the client? It hangs. This one on the left, this is going to crash. Sorry. Whatever. They do this. So just stop the server. This is it. There doesn't seem to be any answer for that yet on Google when I check. Way to solve that. Anyway, these files are on GitHub already, and you can pull those and make your own tests if you like. But since, like I said, what I'm going to do now is run these same tests on a couple of internet connected servers in other parts of the world. Let's set that up. Going to create a droplet. I'm going to create the cheapest droplet, £5 a month, and I'm going to install this droplet in Singapore. Okay, and I'm going to call this one. This will be my server. Create. Okay, so that's my server. I'm going to create another one now, another droplet. And once again, it's going to be just a dirt cheap one, the cheapest one. And this one's going to be in Frankfurt. And this one's going to be called my client. Client create. So these two things are creating now, the server and client. And what I'll do is I'll get those files from GitHub, and I'll run them and fast forward the video until I can actually test that. Putty. Git clone. Okay. CD Sean's gRPC. Okay, so that took a little while to get pip to work, but you can just do a search on Google or rewind this video and watch it in slow motion to see what I did. I just typed the problem into Google and got the answer. Anyway, so that requirements have now been installed. Let's try it. Python server.py. Okay, so the server is running now on one of those IP addresses. That's the one I got that was in Singapore. So there's a little server running in Singapore. Let's just put that aside and now go start up a client. That's the client IP they've given me. So I'm going to call that client. And I'll save that. Yep. Let's connect to the client now with putty. Okay, now let's clone that repository. CD Sean's gRPC pip install r requirements.txt. Radio. Now let's I need to set the IP address, change it from localhost. So nano client.py. There we go. So the IP address won't be localhost 9999. It will be 128.199.102.218. Save that. Let's try that out. Python client.py. Doesn't look good so far, unless it's just super slow across the network. Let's put them side by side so we can see the server. See the server as well. Server running, it's got 3 threads, so I'm getting a connection at least. So it's taking a while to do the 10,000, I guess. What I'm going to do is I'm going to start up. So I've got 3 thread counts there. And I'm just going to open up and view the processor performance on each of those. Okay, so there's the server. Login as. See if I got htop. Yes, I do. So we can look at the CPU, what it's doing. It's a 1 CPU server thread count. We haven't got anything yet. Same thing here on the client. I'm gonna view the CPU. Alright, so htop. CPU is maxed. No, it's not. RDO. Oops. Didn't want to do that. Okay, so we're not really. It's going to take a while to get 10,000 by the looks of that. It's typical. When you run things locally, they can be super fast. So what I'm going to do is reduce the numbers it's expecting me to count. So let's have a look here. Nano client. On this side, I want to print every. Let's say I print every 100 messages. I will print out to the console. Control X, yes. And on this side, Nano server, I will print out every 1,000 calls. So if the counter is 1,000, excellent. Control X, yes. Let's start the server again. And let's start the client. Oops. Start the client. Thread count 2 on the left. Now it's thread count 3, so we have a connection. CPUs don't seem to be working very hard. Thread count 3. There we go. There's 100 messages. Oh, you know, when you do this across a network, it's two servers, well, 2 computers, 2 virtual machines on either side of the world. This one on my right, this one's in Frankfurt. This one on my left, this one's in Singapore. And I've only sent 200 messages from the client. This is not fast enough. I'm going to set up the multiprocessor now. There's 300. I think the bottleneck is the network. Just going to Control C there. That's stopped that. I'm going to maybe get it to print a little less than 1,000 now. I'm going to get it to print 100. For every 100 calls, I'll print every 100 calls. Excellent. So yes, let's start that little server again. Oops, wrong one again. Start the server, Python server, thread count 2. On this side, I'm gonna start up multiprocess. oops, Python multiprocess. I think if I remember correctly, I had 2 processes running. 100 calls in 24 seconds on the left there. Sorry that the font is so tiny. Okay, so I've got 2 process IDs, 7333 and 7332, and they're both sending 100 messages each, and they have to wait. So that's 100 calls in 8 seconds. I mean, running locally is just way faster. What happens if I now hammer that from this computer here? I'm going to start up a multiprocess here, and at first I'm just going to update my client IP to being the server, which is 128.102.102.218. Okay, let's just start up a multiprocess there. Let's see what happens. Multiprocess. Okay, so we've got 3 clients. Oh, it's nice and slow. I'm now in London trying to get calls to my doesn't seem to be working very well. That's because I'm doing 1,000, aren't I? If I go off to client and print out every 100, there now, let's start that up again. Python multiprocess. Let's have a look what's going on here. Got a thread count of 3 on the server. Let's see how this other client over here, I've got 1,100 messages sent. There's 2 process IDs. There's it's taking quite a while. Right, so this server in Singapore is now being pounded by 2 different clients, each with 2 processes each. So still processing 100 calls in 4.2 seconds at the moment, 100 calls in 4.3 seconds. Anyway, I'll let you mess around with that yourself. I'd like to, if you've seen anything I've done wrong, or you'd like that I should do differently, you can make a pull request to my GitHub project. Thanks for watching. Remember to like, comment, subscribe, and share.